sure it is actually recording. Yep. Okay. All right, so this is Traverse. It's called Traverse because this is how we do what we call depth first search in a maze. Okay, if you want to explore a maze, this is how we do it. So let's go ahead and just get started with this one. It's going to take a little bit longer to trace this one. It would take the majority of today's class just to trace this one algorithm. All right, so let's go ahead and get started. We need one column for comments. I'm going to change the font size a little bit later, but right now I'm just going to put in all the necessary columns first. So I'll just make this one a little wider because we do have a conjunction here to evaluate. And I'll bump up the font size on this side and bump it down on the other side, just so that we can fit everything that we need. Okay, now we need to talk about the precondition. When you analyze algorithms like this, the first thing you want to do is to just kind of go through all the subroutines and identify whether we have any global variables or not. Okay, so in this case, when you look into Traverse, the names that the subroutine refers to would be sum, H, A, and that's it. Okay, and every single one is accounted for because sum is a local variable, H is a by-value parameter, and A is a by-reference parameter. So these names are all accounted for. They cannot be global variables. Now you look at the next subroutine, which is main. Main has references only to A, which we already know is a local variable, so it's all accounted for. And that's why we don't have any global variables in this particular program, which makes the precondition very easy to state because that's it. Okay, we don't have any global variables to say anything about. The first line that is outside of the subroutine, the definition of a subroutine is line 26, and that's where we start. Because main does not return a value, it is okay to use return line number, and it is just post, which is the line following the invoke statement. But we also have to allocate for the local variable in the subroutine main. In this case, it is local variable A. Local variable A is an array, so it's going to take up 7 columns all by itself. So we have A bracket 0, 1, 2, 3, 4, 5, and 6. There we go. And because A as an array is a local variable, all the values inside this array, they have to be uninitialized. So we have to use a question mark to represent that the value of each column is undefined at this point. I should not say undefined because in the context of C, it is defined, it is just unknown. Okay, we just don't know what it is, but we know it's an integer of some kind, but we just don't know the value of the integer. Okay, so now we are all done with the allocation of the columns. We continue execution in the subroutine, which in this case is just main. I'm not going to waste too much time to do the initialization. I will just collapse line 17 to 23 into one single line here so that we have more time to trace the rest of the program. So from line 17 to line 23, we'll initialize the entire array to 4, 3, 6, -1, 5, -1, and 4. And then we continue on to line 24. Line 24 is like this. Okay? So the last thing we want to do on line 24 is to print out the value. We can print to the printer, print to the screen, print to something. We don't know where we are printing to, but that's okay, because we can't even do that yet until we figure out what the invocation is going to return. So the first thing we have to do on line 24 is to invoke Traverse with these parameters, figure out its return value, then we can print the return value to the screen or a piece of paper. So that means it is time to set up everything. I'm going to use the split screen technique here. In fact, I'm going to hide all the other columns because I can see the values of the array in the pseudocode itself. So there's no need to show those columns, throughout the execution of this trace, of this pseudocode. So on line 24, we want to invoke Traverse. Now, Traverse does return a value. It returns sum. So we have to use return info instead of return line number. And for return info, it has to tell me when the invocation is done, where are we going and what else do we need to do on that line. That's what return info is supposed to tell us. So in this case, when the invocation is done, we should go back onto line 24, and what is remaining to be done is the printing of the return value. So that's why we set up column K, or return info, the way I just specified it here. Are there any questions about this? Okay. The question mark is a placeholder of the return value. And then the next thing we have to do is to allocate for everything that the subroutine needs to use. So in this case, we have three things to allocate for. One is A as a by reference parameter, one is H, which is a by value parameter, and one is sum, which is a local variable. So those are the three things that we do have to allocate additional columns for, and it is a good time now to take a look at what do we need to specify in those columns. The easiest one is sum. Yes, go ahead.
I put just one A, but I didn't know why I did that. It was just like how you have it here, even though it looks like it's comparing this to the A and then the low arrow.
Are you referring to line 24 here?
Yeah.
Well, the one on the left-hand side is referring to the local variable A in main, and the one on the right-hand side is referring to the by reference parameter A of traverse. So those two A's are completely different. They just so happen to have the same name.
No, how come you wouldn't? So you would not have a second one A.
I would have a second A on column L because the parameter needs its own column. So in this column, in column L, that A refers to parameter A of traverse, which is an alias to the same columns, corresponding to the local variable A in main. But we'll deal with that later. Okay, we'll deal with the easiest one first. The easiest one is sum. It is a local variable. It starts with an unknown value, so it always starts with a question mark. H is also easy because it is passed by value. Anything that's passed by value, you just figure out what is the value of the expression to the left of the right arrow, and in this to the right arrow. In this case, it's just a constant of 0. So H as a by value parameter starts with a value of 0. Now A as a parameter is a little bit more tricky because it is passed by reference. Now we know it is passed by reference because you can see the double-sided arrow here, as well as by ref inside the definition of the subroutine. Anything that is passed by reference means that the parameter becomes an alias of either a particular column or a whole bunch of columns. In this case, it is an alias of a whole bunch of columns because I use array A to specify parameter A, and array A is taking up, if I go back a little bit here, it takes up column D to column J. So that means parameter A is going to be an alias of all of those columns, aka columns D to column J. So that's how we set up the columns when we invoke traverse. Are there any questions at this point? This is the first time we invoke traverse. Any questions? Questions? Okay. After we set up all the columns, we can go into the subroutine starting on the first line in the subroutine, which is on line 5. On line 5, we initialize sum to 0. On line 6, we evaluate the condition of the conditional statement, which is H is greater than or equal to 0. Is that true?
Yeah.
Yep. Okay, H has a value of 0 at this point. And then the second condition, in the conjunction is H is less than bar A bar. Is that true?
Yes.
Okay, because bar A bar is 7, 0 is less than 7 is true. We have true and true, which means the entire expression is true. So we have to go into the then branch starting on line 7. Line 7 to line 11 is a loop, which constitutes the entire then branch. So the loop has its own condition to evaluate, which is H is less than bar A bar. Yeah, we just confirmed that was true a little bit earlier, so we don't have to talk about this one. And the second one refers to the value of an element in array A, or the array that A is referring to. So in this case, parameter A refers to column D to column J. column D to column J corresponds to array A in main. And we are looking at the first element because the index is 0. The value is 4. 4 is less than bar A bar, which is 7, is also true. So this time we also have true, and as a result, the entire conjunction is true. We have to go into the loop to perform one iteration. So we go to line 8. Line 8 is sum gets sum plus invoke traverse, blah, blah, blah. So that means it is time for recursion. We have to set up the columns again for the second invocation. Yep, go ahead.
You did the wrong, the sum of while statement. You did the wrong,
Yeah, it's less than 0.
Oh, okay. I caught the wrong thing here. It's greater than or equal to 0. Thank you. It turns out to be true too.
Still true.
Yes. Okay, but that's actually a very important part because that's the one thing that will stop the recursion is A bracket H is greater than or equal to 0. Okay. All right. So now that we are on line 8, we have to set up the additional columns. Now, when we look at the invocation on line 8, it's not that complicated. We use A, which is a pass by reference parameter to me. I'll pass it by reference again to the next subroutine, which is also traverse. We just pass the reference along. So that's not the difficult part. The more difficult or tricky part is using A bracket H to specify the new parameter H. So what we need to do is to figure out what is H at this point. H is 0 at this point. So A bracket H is A bracket 0, which is the value of the first element of the array referred to by parameter A, which is a long way of saying 4. Okay? So what I'll do is I'm just going to copy and paste a whole bunch of stuff here to columns O, P, Q, and R. I only need to adjust return info and also H here. A, because we are passing a reference along, so parameter A is still an alias of columns D to J. So that part is not changed. We do have to change return info because this time the invocation is on from line 8. When we are done with the second invocation of traverse, we have to get back onto line 8 to finish up the addition and then the assignment operation. So that's what we'll represent here is we have to go back onto line 8. The assignment needs to be done, and that can only happen after the addition is done too. Okay. So we modify the return info for that. And then H, as we just talked about, is the value of the first element in the array, which is 4. And that's how we set up the second invocation of traverse. Now, after we set up all the columns, we can now continue execution in the subroutine. And let me just make sure that the size or the width of the columns are adjusted. Here we go. So now we continue execution in the subroutine that we are invoking, which turns out to be traverse again. So that means we continue execution on line 5. Pretty much the same thing. H is greater than or equal to 0 is true because H has a value of 4 at this point. And sorry? Oh, we have the initialized sum first. Right. Okay, thank you. And then we get on to line 6. And line 6 is evaluating H is greater than or equal to 0. That is true. H is less than bar A bar is also true. So true and true is true. Once again, we get to line 7, which is the condition of the loop. H is less than bar A bar is true. Now this time we have to look at this one. This is the one that we really have to look into, is if I use H as an index to go to an element in the array, is the value of the element, greater than or equal to 0? Is it non-negative, basically? H is 4 at this point. We are looking at the 5th element in the array. And the 5th element in the array has a value of 5. 5 is greater than or equal to 0. So we have true and true again, which is true. So we go in for another iteration. So right now, when we get to line 8 here, it is kind of worthwhile to note that we are actually inside one loop in one invocation, and we are now into another loop in a second invocation of traverse. Okay. Now that part will become apparent when we get back onto line 8 and finish this iteration. Then we'll see, oh, okay, we might have to go through another iteration. On line 8, it's the same thing. We have to invoke traverse, so that we can finish up the addition and then the assignment operation. So in this case, I'm just going to copy and paste the whole thing, with only one exception. The parameter that I use, the value that I'm passing to h is a bracket h. So in this case, a bracket h is a bracket 4, which has a value of 5. So this is the only part I have to change after I copy and paste. So I copy, and then I paste here. And let me just resize the columns first. This is the only one that I have to change to a value of 5. And then we continue execution in the subroutine that we are invoking, which is traverse. So we get back onto line 5. Are there any questions at this point? So this subroutine is not that complicated up to this point. It's just like most of the recursive subroutines that we talk about in the class. We just keep setting up more and more columns. Okay, but what makes this subroutine interesting is when we go back, we have to go forward again, so that it goes back and forth, quite a few times. Not quite a few times, just 3 times. So back on to line 5, we have the initialized sum to 0, and then we move on to line 6. So this time we have to once again evaluate the condition of the conditional statement. H has a value of 5, is greater than or equal to 0, is true. So now as a conjunction, we have to evaluate the other one. H has a value of 5. 5 is less than bar a bar, which is 7, is also true. Then we move on to line 7, which is the condition of the loop here. We have h, which is 5. 5 is less than 7, is true. And now this time we have to look up, a bracket h. H is 5, so we are now looking up the value of the 6th element in the array, which is initialized on line 22. So now it has a value of -1. -1 is greater than or equal to 0 is false. So we have true and false, which makes the entire thing false. Okay. So if line 7 has a condition that is false, where do I go next?
15.
We go to line 13, that's right. Because when the condition of line 7 is false, we get out of the loop. But when we get out of the loop, it is the only thing in the then branch of the conditional statement, which also means we get out of the conditional statement. So that's why we end up on line 13, because we do not trace line 11 or line 12. So when we get to line 13, it's a very simple return statement. It returns the value of sum. Sum has a value of 0 at this point. When we execute a return statement, we look up the rightmost return info cell, just copy and paste it, change the question mark, which is a placeholder, to the value that we are supposed to return, and that's it. Okay, so that's how I changed the font size, didn't I? No, I didn't change the font size. It's just a different view of the algorithm. I'm just going to hide it for now. Okay, so we just changed the question mark to the value that we are returning, and the return statement is done at this point. Then we move on to line 14. Line 14 has 2 things to do. The first thing it has to do is to make a note of what do we need to do next. That's based on the return info cell. So we just copy and paste the return info cell here. If you want to, in the exam, in the final exam, you can just say line 8. That's okay. Okay? But in your mind, you have to remember what line 8 looks like at this point, because we have just resolved the invocation. So that's something that it's an option to you. Okay? You can choose to do it the same way that I do it in class at this point, or you can do it in the way that the notes is demonstrating. So either way is okay, but I think this way is more clear. Okay. The second thing it has to do is to deallocate those columns. Now the order is actually important. Even though in this class, it doesn't seem to make any difference. I can deallocate first and then copy and paste, the return info cell. It doesn't seem to make any difference. And that's because nobody else is going to use up these columns, because I'm the only program executing here. But when you're running this type of program in an actual system, there can be things happening in the background. So as soon as you deallocate a column, the content of the column can be gone right at that point. So you cannot count on a column retaining its value as soon as it is deallocated. And that's why the order is always make a note first where we are going to continue execution, and then we deallocate those columns. And that, that's actually important in a different context. Now that we are back onto line 8, this is what line 8 looks like at this point. That's simple to do. We are just adding 0 to sum and then store the value, the sum, back into the variable sum. But I have to change the columns because I'm no longer looking at columns STUV because these columns are now deallocated. So I have to shift my view back into columns O, P, Q, and R, and sum is now referring to column R. So column R is the one that is getting changed. Well, quote unquote getting changed because 0 plus 0 is 0, and we are storing the 0 back into column R. Yep.
Scroll up.
Say again?
Can you scroll up?
You need to scroll up. Oh, okay, because of the view. Like that? Okay. Let me do this instead. Okay, I'm just gonna change the screen here. Is that okay? Can you read the bottom? Okay. So this way I don't have to keep, moving it up. Yeah. All right. So we are done with line 8. Now we move on to line 9. Line 9 is printing A bracket H. H at this point has a value of 4, so we are printing the value of the 5th element in the array, which is 5. So we just make a note of that. We are printing a value of 5. And then we move on to line 10. Line 10 is adding 1 to H. H is column Q. At this point, it has a value of 4, so we'll change that to 5. And then what do we do?
7.
We go back to line 7 because we are now at the end of a loop. Okay, I'm hoping that everybody still remember how to handle a loop, because we don't really deal with a loop often when we have those examples in subroutines, but it works exactly the same way as loops, outside of the context of a subroutine. So we get back onto line 7, and line 7 is going to ask, is H less than RA bar? The answer is yes, okay, because 5 is less than 7. And then the second question is, if I use H as an index into the array, is the value of that element greater than or equal to 0? No, that is false, right? Is that okay? Because we are looking at the value of the 6th element in the array, which is a -1. -1 is greater than or equal to 0 is false. So that makes the entire conjunction false. And then we go to line 13. So we return a value of 0 again. Okay, because if you look at sum, okay, I have to split the screen again. So that the top portion will show us the header, and then the bottom portion is where we are actually tracking it. So this time sum gets a new, quote unquote, new value of 0 again. Nope, sorry, I take it back. We're executing the return statement. So we take the value of sum, and then we use that to change the value of the question mark, copy and paste it, and just change the question mark to the value that we are returning. And we are done with line 13, move on to line 14, same thing happens. Copy and paste the return info cell to make a note of what we are supposed to do after this, and then we deallocate the 4 columns for the invocation that is ending at this point. Are there any questions? Okay. So now we're back onto line 8. But I also have to remember to change my context because columns O, P, Q, and R are now deallocated. So I have to switch back to the other 4 columns were allocated earlier, which are columns K, L, M, and N at this point. So I'm referring to this sum of column N. We add 0 to it and then store it back into the same column. So sum is getting, quote unquote, a new value of 0. And then we move on to line 9. Line 9 is printing A bracket H. h at this point has a value of 0, which means we're referring to the first element in the array. It has a value of 4, so we're printing a value of 4 at this point. We move on to line 10. H gets incremented. H is column M. It was 0, now it is 1. And then we go back to the beginning of the loop, which is on line 7. Are there any questions at this point, with this trace? It's okay so far? Okay. What do we do on line 7? Well, we have a condition to evaluate. H, which is 1 at this point, is less than 7. That's true. A bracket H, which is A bracket 1, has a value of 3. 3 is greater than or equal to 0 is also true. True and true is true. So now we have to continue with a second iteration of this loop, and this is the first invocation of traverse. Is that okay? We are in the second iteration of the loop of the first invocation of traverse. Okay. So we get back onto line 8. And line 8 is the same thing. It looks about the same. But this time we have to reallocate some of the columns. In other words, every time we invoke a subroutine, we are allocating columns based on what are the leftmost available columns. At this point, the leftmost available column is actually column O. So those are the columns, column O, P, Q, and R are the 4 columns that I'm going to allocate in this case. So once again, we reallocate. Well, not once again, this is the first time we reallocate columns O, P, Q, and R. So we have return info, A, H, and M. Return info looks pretty much the same as last time because we're going back onto line 8 to finish up the summation. So it looks about the same. A is still the same. It is still the alias of columns D to column J. H, this time, okay, well, let's take a look at H here. I use A bracket 1 to specify the new value of H. So what would be this value here? 3, yep. And sum is a local variable, starts with an unknown value, therefore it gets a question mark. And then we continue execution. In the subroutine, starting on line 5, it initializes sum to 0. Then we move on to line 6. Line 6 is evaluating H is greater than or equal to 0. It is true because H has a value of 3. H is less than bar A bar is also true. So the entire conjunction is true. We move on to line 7. H is less than bar A bar is true. A bracket H has a value of what? We are looking at A bracket 3 here. Has a value of -1. -1 is greater than or equal to 0 is false. So we have true and false, which makes the entire conjunction false. We skip all the way to line 13. It returns sum. Sum currently has a value of 0. So we copy and paste the return info cell, change the question mark to 0 because that's the value that we are returning on line 13. We get on to line 14. Got 2 things to do. Make a note of where we are supposed to go next, and then we deallocate those 4 columns. Are we still doing okay at this point? Okay. If you feel boredom, that's a good sign. Okay, because we are literally doing the same thing over and over and over again. All right, so we're back onto line 8, but I'm in the wrong context at this point because I should not be looking at columns O, P, Q, and R. Those 4 are now deallocated. So we have to switch back to columns K, L, M, and N. Sum is column N. It has a value of 0. 0 plus 0 is 0. And we store that back into column N. So this is the second time column N gets changed to 0. Okay. Well, the third time if you include the initialization. Then we move on to line 9. Line 9 is printing the value of A bracket H. H has a value of 1 at this point. A bracket 1 has a value of 3. So we print a value of 3 at this point. And then we move on to line 10. Line 10 is adding 1 to H. H goes from 1 to 2 at this point. And then we go back to line 7 to reevaluate the condition of the while loop. 2 is less than 7 is true. A bracket 2 has a value of what? Has a value of 6, right? And 6 is greater than or equal to 0 is true. So now we have true and true. We have to perform another iteration. We get on to line 8 again. There's an analogy, okay? When you trace through this thing, it looks like it's doing something that's really crazy. It's actually resembling the exploration of a maze. Okay, so I'll give you a picture, a pictorial representation of another way of looking at this particular algorithm or the trace of this algorithm. So now we are getting back onto line 8. We have to do the invocation first. We allocate the leftmost available column, which turns out to be column O again. So we're getting back to column O, P, Q, and R to store return info, A, H, and sum, question mark for this guy, and 6 for this guy, because we are looking at A bracket 2, which has a value of 6. A is still an alias to columns D to J. And return info is the same as last time, which is we are going back to line 8 to finish up the addition, and then we can finish up the assignment operation. Then we move on to line 5 again to initialize sum to 0. And then we move on to line 6 to reevaluate the condition of the conditional statement. H is greater than or equal to 0 is true because H has a value of 6. H, which is 6, is less than 7 is also true. True and true is true. Get to line 7, which is our while loop here. H is 7, H is 6, 6 is less than 7 is true. A bracket H is A bracket 6. It has a value of 4. 4 is greater than or equal to 0 is also true. So now we have true and true, which is true. And now we get to line 8 again. All right. So at this point, I'm going to kind of shortcut a little bit, because otherwise I can take up the entire class to trace this. Okay. Well, there's a reason why I can kind of shortcut this part, because I've done it already. I've done it already. Because on line 8, at this point, I'm going to use A bracket H to specify this H here. Now, if you look at H, it has a value of 6. A bracket 6 has a value of 4. Haven't we seen that a little bit earlier before? When we start, H with a value of 4 when we invoke traverse. So, since I'm lazy, I can just kind of copy and paste it. Because have I done any changes to elements in the array? Nope. So that means the only one thing that traverse that can affect the behavior of traverse has not changed at this point. So that means it's going to do exactly the same time as last time when I specified a value of 4 in parameter H. Okay, so this is why I have the third window open here, so that I can easily quickly locate the part where H has a value of 4, which is this part here. So now I can take pretty much this entire block here and say, oh, it's going to do exactly the same thing. Now the columns are different. It is now shifted 4 columns to the right-hand side. But I can still copy and paste this content into the new location. So the new location is going to be over here, because they're exactly 4 columns over compared to last time. So I can just copy and paste the entire thing. Now that's okay, but I also have to copy and paste for the comments column as well as the line number column. So I go back to the big map here, and I just look up, this is from row 12 to row 29. So I will copy this portion also from row 12 to row 29, but this time only applies to columns A and B. So I make a copy here and paste it over here. And instantly we are done with that portion of the trace. Does everybody understand why I could do this? Okay. So instead of actually spending the time to do it, I'm just shortcutting that part. And we are now back to line 8. And the context, this is the tricky part, is what is my current context? So I have to scroll to find out my current context. And that would be my current context at this point. Yep, okay. So that's my current context, and I'm on line 8 at this point. So this sum, which is column R, is going to get a new value, quote unquote, new value of 0. And you can see that sum never changes, it's always 0. But that's okay. I mean, there's no right or wrong because I didn't tell you what the algorithm is supposed to do. So without an expected behavior, you cannot say it is wrong. It doesn't crash either. There's no infinite loop, so we just trace it. So after that, we move on to line 9. And line 9, let's switch back to the algorithm here. On line 9, we print a bracket h. H is 6 at this point. A bracket 6 has a value of 4, so we just print a value of 4. Then we go to line 10, we add 1 to h. H goes from 6 to 7. And then we go back to line 7. Now this time when we get back onto line 7, we reevaluate h is less than bar a bar. That becomes false already, because h has a value of 7, bar a bar also has a value of 7. 7 is less than 7 is false, and since I'm using short-circuited evaluation, I don't even bother to evaluate the right-hand side of the conjunction. So from line 7, we move on to line 13. We perform a return. We return sum. Sum has a value of 0, so we are returning a value of 0, changing the question mark to a 0. Then we go to line 14. We make a note of where to continue execution, and then we just say, okay, these 4 columns are no longer of use to me. Deallocate those columns. And now we continue execution on line 8. So we have to scroll back to reestablish our current context. It's important to note that h has a value of 4 at this point. And the header of the columns is over here. So on line 8, we are evaluating 0 plus 0, and that's the new value of sum. So we put another 0 here. We move on to line 9, which is printing a bracket h. Yep.
Going back to line 7.
Yep.
It says if while h is less than a, and then AH is greater than 0, AH doesn't exist.
Yeah,
So the algorithm
That's okay, because of short-circuited evaluation, when the first condition, which is h is less than bar a bar, when that gives me a value of false, because of short-circuited evaluation, I just stop right there and say the entire conjunction has to be false. And that's why I don't even bother to evaluate the right-hand side, and that's how I avoid that problem of accessing an element out of bound.
If you're comparing to something that doesn't exist, wouldn't that throw an error?
But I don't even bother to do the comparison.
But should we?
I did that.
Should we?
I did the same thing, and I just like, if the 7 doesn't exist, that's how I stopped. My turn, and I tried to do it all over again.
No, you just use short-circuited evaluation, which means when the student. Okay, so let me finish this print statement first, and then we'll go back to row 71 in the trace. Okay, so we are printing a bracket 2 at this point. A bracket 2 has a value of 6, so it's going to print a value of 6. So I'm going to stop and pause here, and then we go back to talk about row 71, which is this row here. Okay. So at that point, at that particular point, the context is not columns K, L, M, N. The context, because that's before we deallocate those other columns. So this is our current context at that point. So at that point, the context is like this. Okay. So that's our context when we execute line 7 on row 71 of the trace. Parameter h has a value of 7 at that point, right? So we are comparing 7 to bar a bar. Bar a bar is always 7. 7 is less than 7 is false. Is that okay so far? Okay. So we now know that the left-hand side of the conjunction is false. With a conjunction, if at least one side is false, the entire thing is guaranteed to be false. So using short-circuit evaluation, which is also called lazy evaluation, I can just stop here and say, okay, the entire conjunction is false. I don't even bother to evaluate a bracket h is greater than or equal to 0. And that's the whole point of short-circuit evaluation, is we can kind of shortcut the whole thing. Yep.
Now, since it's logic, like A and B, isn't it equivalent to B and A? So say you decide you chose to phrase it as B and A instead of A and B, wouldn't that cause a problem?
Yeah.
That is why this is a computer science class and not a math class. Because in a math class, the math professor will tell you that A and B is B and A. It is commutative. But in computer science, it is not commutative because all popular programming languages, they all use short-circuit evaluation when it comes to conjunction and disjunction. Okay. So we kind of talked about this right after we talked about searching in an array. And it is really, really important because people do write code like this. Okay, they use condition in a conjunction. The first one, okay, let me just kind of point out which one I'm talking about here. Okay, in this particular one, this condition, which is the one on the left-hand side, is sometimes called a guard condition for the second one, for the one on the right-hand side, because it's basically guarding it to make sure that if I do evaluate the one on the right-hand side, h has to be okay. Because in order for me to evaluate a bracket h is greater than or equal to 0, h is less than bar a bar has to be true first, which means h is a valid index by the time I get to the right-hand side. So that's why it has also has a nickname of being a guard condition. Any other questions? No other questions? Okay. And this is really why, I was only half joking when I said, this is why this is a computer science class and not a math class, because a lot of stuff to a mathematician is, it means one thing, but in programming, it means something similar, but not exactly the same. Okay. So after this is also the other thing, I want to kind of point out is when we do a trace, we can stop at any time, go cook, a dinner, and then we can come back and continue the trace because the entire state of the program is represented on a piece of paper or in a spreadsheet at this, in this case. And that's really handy because I don't have to remember a single thing. Everything that I need to know about this pseudocode to execute it is represented in the spreadsheet already. So now I can continue my execution. I'm done with line 8, and I can look up my current context. And columns K, L, M, and N, would be my current context. So I can scroll this back to look at the labels of those columns. There we go. All right, so we're now on we are done with line 9. We are now moving on to line 10. Line 10 is adding 1 to h. So that part gets a little bit harder because I have to look up h. h has a value of 2 at this point. Adding 1 to it will turn it into 3. And then we move on to line 7, the beginning of the loop. And we evaluate the condition there. H is less than bar a bar is true because h has a value of 3. A bracket 3 has a value of -1. -1 is greater than or equal to 0 is false. So this time we have true and false, which makes the entire thing false. Now, the question is, well, but in this case, since we are lazy, can't we just say that a bracket h is greater than or equal to 0 is false, and not evaluate the left-hand side? Well, the answer is no, because when we use short-circuited evaluation, the ordering of evaluation is always from left to right. Okay? So in programming, it is not arbitrary anymore. You cannot say, well, we can evaluate one side first and then the other side, which side is evaluated first doesn't matter. It does matter when it comes to Boolean expressions. It doesn't matter when you're dealing with multiplication or addition or subtraction, but it does matter when it comes to conjunction and disjunction. All right, so now that we know it is false, we get out of the loop, we get out of the conditional statement, we get to line 13. Line 13 is returning the value of sum, which is 0. So we take the return info cell, copy and paste it, change the placeholder to the value that we are returning, and we're done. We get to line 14, the end of the subroutine, make a note of where we are going next, and we deallocate the 4 columns that we use for this particular invocation. And now we continue execution on line 24. Line 24 is just print 0 at this point, so we'll go ahead and print that 0. We're done with line 24, we get to line 25. I have to change my context to the previous 8 columns, in this case. So this time we look up a return line number. It tells us that we have to, oops, that's not right. Okay, after line 24, we go to line 25. I mistyped. So line 25 is the end of a subroutine. We look up the return line number. It tells us to continue execution at post, make a note of that, and then we deallocate all the columns that we allocated for this particular invocation. And then we're done. We continue execution at post, and we're all done. Okay, so so this one is a little bit different. I'm pretty sure most of you realize that in many of the recursive algorithms that we have done in the past, we could have easily turned those things into a loop, right? Factorial is a good example. Okay, we start with a value of, let's say, 4. Okay, so in a recursive definition, we say, oh, 4 factorial is 4 times the factorial of 3. And then we have another invocation to deal with the factorial of 3. So we say, oh, the factorial of 3 is 3 times the factorial of 2. So now we invoke factorial again with a parameter of 2. So we keep doing it like this in a recursive way. But we could have done it using just a loop, right? We initialize product to 0. To 1, excuse me. And then, in the loop, we just go from the lowest value to the highest value. We have another index or another variable. While I is less than or equal to n, product is product times I, and I gets I plus 1, then we can just do the whole thing in a loop. That approach doesn't work here. Okay? This one, if you kind of think about it, it's almost like, each one is an entry in a file system. If the entry is a number that is non-negative, it means it's a folder. So in this case, this is a folder, this is a folder, this is a folder, this is a file, this is a folder, this is a file, this is a folder. So when I want to remove a folder, I have to make sure the folder is empty first. And so that's why the recursive definition works in this case. There's another view to look at this thing here. You can look at it kind of like a maze, okay? Okay, so as a maze, we start off at the entry point to the entire maze. So let's say this is the entry point to the entire maze. So we start here, okay? So when we get into the maze, we have basically 3 doors, okay? Because when you look at the entries 0, 1, and 2, they actually kind of represent 3 different directions that we can take within the first chamber in the maze. So we're kind of looking at a chamber here that has 3 doors. Are we doing okay so far? Okay. The first door, quote unquote, has a value of 4. So that leads me to one place. The second one has a value of 3. It leads me into another direction. And then the third one has a value of 6, which leads me to yet another direction. Okay, so I'm just going to comment this one is 4 here, and this one is 3, and this one is 6. Okay, this guy has no particular value. The first chamber has no value. Now, when we go to 4, you can see that it has one option open, which is 5. So when we get to 4, it connects to another chamber, which we'll call 5. Okay? But when you get to 5, A bracket 5 is a dead end. Okay? -1 is representing a dead end. So when we get to 5, you can say, oh, okay, that's a dead end. There are no, it doesn't lead to any other places. Okay? So when you're exploring a maze or a building or some place that you have never been before, you walk into a closet. What do? You turn around and see whether there are other places that you have not explored yet, right? So that's why we turn around, after we explore 5, we turn around back into 4. But when you look at 4, there are no other places to look either. So we turn around again, we get back into the first place. And then we move on to the second door of this maze, which has a value of 3. So 3 by itself is also a dead end, so we have another closet here. What makes this kind of interesting is the third alternative from the starting point, because here's room 6 here. Room 6 is represented by A bracket 6. It has one alternative, and that one alternative connects me back to room 4. And that's why we were re-exploring that portion of the maze. We do not leave anything behind, so we cannot remember and say, oh, we have been here before already. There's nothing in this code to do that. And that's why we were re-exploring 4 and 5 in this case. So that's one way to look at this algorithm, or the trace of this algorithm, is we are actually just exploring a maze using what we call a depth first search order, which means we go as far as we possibly can, but when we get into a closet, we turn around. Okay? What makes this algorithm difficult to do without recursion is when we backtrack, we have to remember, oh, but is there another alternative that we can explore here? And then the other thing you also have to do is to remember this is a one-way street, so we can only go in this direction. Because otherwise, you can say, oh, from 4 we can go to 6, but it doesn't really work that way in this case. Okay. Are there any questions? I can see one question in your mind. Are we going to have something this nasty in the final exam? Well, the answer is yes and no. The yes part is I will give you a snippet of a trace. In other words, I will basically take a snapshot at any particular point of this trace. So I can give you an example here. I can give you the entire view of the whole thing, and I can say, oh, I'm going to take a snapshot of this particular line. Okay? And all the state of all the columns at that point. And then I'll just ask you, well, trace this until we have returned once, okay, or execute the return statement twice or something like that, which is not going to be very long. I mean, if I just look for one single return, that means you only have to go from row 21 all the way down to here. That's one, one return already. But you do have to understand, how to deal with the whole thing and how to use the trace to help you navigate through the pseudocode. Is that okay? Kind of? Okay. It's 8 o'clock. I posted a few practice tests online already. I'm not going to have enough time to go over all of those, but what I want to do is to show you one example where there's a side effect that negates one of the things that we talk about when we do a pre-post condition thing. Okay, so I will just take one opportunity to illustrate that. But let me show you where to find the practice test, so you can kind of focus on that a little bit. I wouldn't do everything because some of these practice tests were from way in the past when I had time to finish up. Nope, not this one. I think the next one. Topic 9 is the one. Okay. So there are quite a few exposed, or you can access at this point. This is the one that I want you to look at. Unfortunately, I did not zip it. I used tar to create a quote-unquote tar bar out of it. So Windows won't be able to handle it. I will have to post another file that's a zip file, then you guys can unzip it. The way it is right now, you can use 7-zip to open it. It's just not, Windows doesn't natively open the file. If you install 7-zip first, it will still be able to do it. I would start with that one because it doesn't have any questions about records. So that means it's a good representation of what kind of questions you might get for this class. Okay, we have about 20 minutes left. I'm going to give you another example. That's relatively small. It's not. The algorithm itself doesn't really have any purpose other than demonstrating the fact that once we have side effects with subroutines, the whole thing about the precondition of an entire conditional statement can become the precondition of one of the branches. That is no longer true. Once we have side effects, that is no longer true. Okay, so I'm just going to give you a very quick demonstration of what I mean by that. Okay, so we'll have a define sub here, and it's going to be, well, it doesn't really even have to have a particular meaning. So I'm going to have this thing to return, okay, it requires one parameter passed by reference. And what it will do is two things. It will basically say, x gets x plus 1, but it will return something else. It's going to return x minus 1 mod 2. I just deleted a whole bunch. Return x minus 1 mod 2, and this whole thing is 0. Okay. That's my subroutine sub 1. It is perfectly okay to write a subroutine like this. It has one parameter that is passed by reference. It has a return statement. It uses the mod, which is the remainder operator. It's perfectly okay. Doesn't seem harmful at all. Okay. Now we have. I don't even bother with a main subroutine in this case. I just use global variables. So in the global variables, I'm going to have my global variable, let's say y here. And y is initialized to a value of 2. And then we can say if invoke sub 1 using y to specify x, then, well, if you look at sub 1, when does it return true? When the original value of x is odd or even? When the original value of x is even, okay? Because we add 1 to it and then we do a subtract 1 to counter the add 1. So we are still referring to the original value of x mod 2 is 0, which means it is even. Okay. So when the subroutine returns true, we can say x is even, right? So we'll just go ahead and say print x is even, else print x is odd. I should say y because that's my variable. So I'm going to go change x to y here and also here. Okay. And we'll go ahead and trace this real quick. This particular pseudocode also demonstrates a kind of uncommon combination in this class, but in general, there's no rule against it either. So you just kind of have to say, well, I guess it is possible to combine things in this particular way. Okay, so we need comments. We have line number. There's a precondition. This time we do have a global variable y in this case. So global variable y starts with an unknown value. And the first line outside of the definition of a subroutine is line 6. Line 6 initializes y to 2. Line 7 is kind of weird. It is a conditional statement or the first line of a conditional statement, but the condition is an invocation of a subroutine. So what are we going to do in this case? Well, let's invoke the subroutine first, right? Okay. It better return a value that is either true or false so that the subroutine can decide which way to go. Is that making any sense? Okay? Because nothing says that a subroutine cannot return a value that is true or false. Now, if a subroutine can return a value that is either true or false, I can use that value in a conditional statement to decide which way to go. So it looks like a weird combination, but it's perfectly okay because one is supplying a value that is either true or false. The other one is making use of the value to determine which way to go. It's okay. So on line 7, now we need to specify return info because when I'm done with someone, I have to come back to finish up the conditional statement because I need to know which way to go. Someone has one parameter x, which is passed by reference. So x is an alias of whatever I use to specify parameter x. I use global variable y to specify x. So that means it is an alias of column C. The return info is going to be the same as the entire line 7. So we're going back to line 7 to finish up the conditional statement. Except the condition of the conditional statement is what I'm expecting when the subroutine returns. So that part becomes a question mark, like that. Are we doing okay so far with this little construct here? Okay? All right. So now that we have set up the columns that we need for this invocation, we get into the subroutine starting on the first line of the subroutine, which is line 3. Line 3 is pretty easy. X gets x plus 1. X is an alias of column C. So column C is the one that is incremented by 1. So that turns y into 3 right away. Then we get to line 4. Line 4 also looks kind of weird because we are doing some calculation, and by now we know what mod is. So it's okay. X has a value of 3. 3 minus 1 is 2. 2 mod 2 is 2 divided by the remainder of 2 divided by 2, which is 0. What is that 0 equals 0 thing? Yeah, exactly. It's a comparison. A comparison is an expression that gives you an answer, a value. In this case, 0 equals 0 is true. Okay? So we are returning a value of true. If we're returning true, what do we do with the return info cell?
True.
We do exactly. We do exactly the same thing as we always do. We copy and paste the entire return info cell, and we say, hey, placeholder here. We now know what you're supposed to be. You're supposed to be true in this case. And that's all we do. The mechanism has not changed, even though it kind of looks like a weird place to have an invocation. Hey, it's perfectly okay. And we don't do a single thing about it until we get back onto line 7. We are now executing line 4. We are not even there yet. So we move on to line 5, which is the end of the subroutine. Got 2 things to do. One is to make a note of where we are supposed to go back to. And then the second thing is to deallocate the columns for this particular invocation. So, and now we are back onto line 7. So this time when we get back onto line 7, the condition of the conditional statement is now known, which is true. So we still have to do the same silly thing here and say true is true, because we want to know whether that expression is true or false. So we say, yes, that expression is true because it is true itself. Right? But that's important because it tells me which way I'm supposed to go. The expression is true, we go to the then branch. The then branch is line 8 in this case, and it's going to say y is even. After line 8, we get out of the conditional statement. There's nothing else to execute. We get to post. So it is kind of weird because y is not even at this point. That's because the condition of the conditional statement is invoking a subroutine. And the subroutine has what we call a side effect of changing something. And as a result, we now have a way to modify the precondition of a conditional statement so that by the time we get to one of the branches or the head of one of the branches, that precondition of the entire conditional statement is no longer the same. And that complicates things a little bit, right? Because when we analyze pre and post conditions, up to this point, we just say, oh, the precondition of the entire conditional statement is still true at the beginning of each branch. But when we deal with subroutines, that may not be true anymore. But don't worry about that. I'm not going to mix subroutines with pre and post conditions. But I just want to show you, the assumption that we have been making up to this point is invalid once we mix in something like this, where things can get changed just by invoking a subroutine. Is that okay? All right. So now is a good time to take a look at the question here. I'm just going to zip it up with a utility right now, so we can, so I can re-upload it and you can download it right away. Okay, turn it on and switch to a command line. Okay, so X, X, zip. Okay, so get back into here. I don't know any other way to zip up a file. Okay, let's add that file back in. This is a Spring 13 actual final exam, so it's not a practice exam in the past. It's an actual exam in the past. It's fx.zip.
Will we be covering this on Thursday?
Yep. Oh yeah. We have to. Because I always give you a practice test before the actual one, including the final exam. So it will be, okay, I think I can get rid of the other one unless somebody wants to deal with a tarball. No die-hard Linux people here, except for myself. Okay, I'm gonna hide it, okay? I'm not gonna delete it, I'm just gonna hide it. Okay, but I do want to show you what's in that folder. Once you unzip, it will give you a folder that is named FX for final exam. And I do want to show you what you will find and what to do with it. It's in my temp folder. Okay. So in the temp folder, when you unzip that file, you will also find a folder called FX, and inside you will find these files. Some are pretty clear. Q1 is a question, and the Q1 answer is the answer to that question. So I do give you the answer to all of those questions. So Q2 has its own answer, Q3 has an answer, Q4 does not have an answer because it's a pre-post condition kind of thing. Q5 has its answer, and there's Q6 that has an answer but not a question. Yeah. And there's one really weird file called q1.pl. Okay, so I want to show you okay, let me show you the question first, and then we'll take a look at what is the PL file. This is the question of that particular exam. So this is the exam like 1 semester ago. Use the following table to look up your test case based on the least significant digit of your student ID, which is your the rightmost digit of your student ID. So if your student ID ends with a 2, then K1 has a value of 4, and K2 has a value of 6. Okay, that's how I set it up in the previous semester. And they are used on lines 13 and 14 to initialize local variables A and B. And here I will ask you, the answer is not a full trace. I'm just going to ask you on which line what is printed. So you just have to give me the values printed on the print statement, which in a way is a good thing, in a way is a bad thing. The good thing is you don't have to give me the entire trace. If you can eyeball and analyze an algorithm and say, oh, I know exactly what it's going to print, it's going to save you a lot of time because you don't have to write down all this stuff. On the other hand, there's no partial credit. Because I'm just looking at the final answer, I don't know how you got to the answer. If you make a silly mistake somewhere along the steps, I cannot say, oh, okay, well, this particular person knew how to deal with the subroutine invocation and all this other stuff, just made a simple mistake here. I'm going to give that person most of the partial credit. There's no partial credit if it's wrong. So I think it's really bad from that perspective. But I do want to show you what the file PL, q1.pl is. Okay, I'm opening it up with GVim here. It's a script. And I'm not sure how far you want to go with this script here. But what it does is when I grade the exam last year or last semester, when I run this program, I give it an argument, okay, which is the ID of the student who is giving me the answer. And this program will print out the entire trace for me. So it will print out not only the trace, but it also prints out the entire, all the print statements. So I can quickly compare, what I'm supposed to see with the actual answer from the exam. So I use a script to help me in the process. So if you guys are interested, you can go ahead and read this. It's a little bit involved, it's a Perl program, but that's basically what it is. Answer only works, well, it does work too, actually. It's kind of cool. Let me see. If I remember right. Okay, where do I put in? There we go. Okay, so this also works too. So what you need to do is to put in your LSB, your least significant digit of your student ID. So if you change this one to a 5, the spreadsheet changes. It just magically changes the value to reflect the proper answer. So I'm pretty sure at least 1 or 2 students in this class, instead of focusing on the trace itself, would look into the cell and say, okay, but what is D4 now? How does this work? How does it know what the value is supposed to be, for a particular test case? But that's how it's set up. I think the other ones are set up the same way. Let's see. There's one without an answer. It's a pre-post condition thing. So we will go over this one. So you definitely, if you want to get more practice with pre and post conditions, definitely work out this one. Okay, work this one out, and then we'll start with this on Thursday just to make sure that we can cover this one. The other ones are kind of more mechanical and more just time consuming. This one, I think both classes, both my morning and evening class, can use more exercise on pre and post conditions. All right, so we are running out of time. I will see you on Thursday. So try to do as many questions as possible. So if you run into any type of questions, you can bring it to the class on Thursday.